The kinetic energy E of a moving object varies jointly with its mass m and the square of the velocity v. If an object weighing 9 kilograms and moving at a velocity of 10 meters per second has a kinetic energy of 450 joules, find its kinetic energy when the velocity is 22 meters per second. To begin with, we'll identify the template variation equation, or the way that these three variables are related. So back up in the problem, we see that the kinetic energy E varies jointly with the mass and the square of the velocity v. As a reminder, joint variation is the same as direct variation with more than one variable. So the variation equation is going to be that E is directly related to both m and the square of v, so we'll have to have v squared here, and both of those are then going to be multiplied by the variation constant k. Once we have that variation equation, the first thing that we want to do is to use the initial conditions that are given in the problem to find the value of k. So when we go back up into the problem, we see that an object that weighs 9 kilograms, moving at a velocity of 10 meters per second, has a kinetic energy of 450 joules. So we're going to plug 9 in for the mass, 10 in for the velocity, and 450 in for E, which is the kinetic energy. So 450 goes in for E, k is the variable we're trying to solve for, 9 is the mass, and 10 is the velocity, but remember, the velocity has to be squared. So to solve for k, we're going to multiply 9 times 100 and get 900 here, and then divide both sides by 900 to solve for k, which turns out to be 1/2. So now that we've found the value of k, we're going to replace the k in the template equation in order to update the variation equation. So 1/2 gets plugged in for k up here, and our updated variation equation becomes 1/2 multiplied by the mass multiplied by the velocity squared. Now we'll use the updated variation equation to answer any remaining questions. And the last question is that we are to find the kinetic energy when the velocity of the same object is 22 meters per second. Since we're looking at the same object and only changing the velocity, that means we're going to use the same mass that we were given in the initial conditions. The mass isn't changing. So we're looking for the kinetic energy. We've already found k to be 1/2. The object still weighs 9 kilograms. It's only the velocity that's changing now to 22 meters per second. So we plug 22 in here, and again, the velocity has to be squared. So our kinetic energy is going to be 1/2 times 9 times 484, which is 22 squared. And all of these values multiplied together give us 2178, and the kinetic energy was measured in joules.